We now determine the equation of the tangent plane to this given surface given by this equation z equals y times of cosine of x minus y at the point 1 comma 1 comma 1. And so this is the formula that we are going to utilize to determine the equation of the tangent plane to the surface. So first I'm going to write down this function, that is the surface function, as f of x comma y comma z by moving this z to the other side. So when we do that, we get y times of cosine of x minus y minus z. So we consider this as the function of x, y, and z. And so we can find the partial derivative of this function with respect to x as well as with respect to y and with respect to z. And then we have to evaluate those partial derivatives at the point and then utilize or substitute into the formula to get the equation of the tangent plane. So this is basically equal to 0. So let's first find the partial derivative of this function with respect to x, which is written as f of x. And so this equals, when we differentiate partially with respect to x, we have to treat y and z as constant. So here this y is a constant. So I just put this y as a constant and differentiate this cosine function partially with respect to x. So the derivative of cosine function is a negative sine function. So I write negative of sine of x minus y. And then we have to apply the chain rule to differentiate this x minus y partially with respect to x. If we differentiate this partially with respect to x, this will be 1 minus a differentiation of y is 0. So it is basically just 1. So I can put this 1 here. And then now we have to differentiate partially with respect to z. So since z is a constant, it becomes 0. So we can just simply write down this as negative of, since we have a negative, I write down this as negative y sine of x minus y. And so we can evaluate this partial derivative at the point 1 comma 1 comma 1. So therefore I write down this as fx at the point 1 comma 1 comma 1, and this means we have to replace x, y, and z by 1 into this equation. So let's do that. It becomes negative 1 times of sine of replace x by 1 and y by 1. So we get sine of 1 minus 1, and this equals negative 1 times sine of 1 minus 1 is sine 0, and the value of sine 0 is 0. So therefore negative 1 times 0 is 0. So we have determined this partial derivative at the point 1 comma 1, 1 equals 0. Now let's determine the partial derivative of this function with respect to y. So let me copy that function, that is f of x comma y comma z, and this equals y times of cosine of x minus y minus z. Now we are going to differentiate partially with respect to y. So we put this as f of y, and we differentiate partially with respect to y. We treat x and z as constant. So when we differentiate this expression, basically we have to apply the product rule. So first I write down this first expression y, and then multiply with the derivative of cosine of x minus y with respect to y. And so this is negative of sine of x minus y, and then we have to differentiate this x minus y with respect to y, and this equals negative 1 when we differentiate this partially with respect to y. So I multiply by minus 1, and now we have to consider this cosine of x minus y times of the derivative of y with respect to y is 1. So we have applied the product rule and found the derivative of this expression, that is y times of cosine of x minus y. We then have this term negative z. Since we are differentiating partially with respect to y, this becomes a 0. So let's put this in simplified form. So we get f of y, and this equals we have a negative here and we also have a negative here. So negative times negative will become positive. So it's basically positive 1. And then 1 times of y is y. So I write down this as y times of sine of x minus y, plus the second term is just a cosine of x minus y. Now let's evaluate this partial derivative at the point 1 comma 1 comma 1. So I write down f of fy of 1 comma 1 comma 1, and this means we have to replace x, y and z as 1. So let's do that. This becomes 1 times of sine of 1 minus 1 plus cosine of 1 minus 1. And so this equals sine of 1 minus 1 is sine 0, and sine 0 is 0. So therefore the first term is 0, plus cosine of 1 minus 1 is 0, that is cosine 0. And so this equals cosine 0 is 1. So we have determined this partial derivative of function f with respect to y at the point 1 comma 1 comma 1 equals 1. Okay, now that we have determined the partial derivative of f with respect to x and y, also evaluated them at the point 1 comma 1 comma 1. Now we will find the partial derivative of f of x comma y comma z with respect to z, that is f of z. And this equals, when we differentiate partially with respect to z, we have to treat x and y as constant. So the first term is completely product of functions y and x. So this is going to be 0, and then we have to differentiate only z with respect to z, which equals negative 1. So therefore f of z equals negative 1. And so when we evaluate this partial derivative at the point 1 comma 1 comma 1, it's going to be negative 1, because it is independent of x, y or z. So we have evaluated this. Okay, so now we have evaluated all the partial derivatives. We can substitute into the tangent equation plane formula. That is, we have to write down fx of 1 comma 1 comma 1 times x minus x naught is 1, plus fy of 1 comma 1 comma 1 times y minus y naught is 1, plus fz of 1 comma 1 comma 1 times z minus z naught is 1, and this equals 0. So let's substitute fx of 1 comma 1 comma 1, which is 0. So therefore this becomes 0 times of x minus 1, plus the next partial derivative, that is partial derivative of f of x with respect to y at the point 1 comma 1 comma 1 is 1. So this becomes 1 times of y minus 1, plus the partial derivative of f with respect to z at the point 1 comma 1 is negative 1. So it becomes negative 1 times of z minus 1. Now let's simplify this. This is 0, and this factor is 1 times of y minus 1 is y minus 1. And here we have to distribute this negative. So it becomes negative z, and negative 1 times negative 1 is positive 1, and this equals 0. We have negative 1 and positive 1. These two gets cancelled. So we have y minus z equals 0. Otherwise, we add z to both sides. So we get y equal to z. Or otherwise, we can see that the equation of the tangent plane is z equal to y. So this is the equation of the tangent plane to the given surface at the point 1 comma 1 comma 1.